This video will talk about similarity. Consider the following figures. How are they the same? How are they different? They are the same shape but not the same size. You can see that the angle measures are the same, but their side lengths are not. The side lengths are, however, proportional, with a ratio of 1/2. This is called the scale factor, which is the ratio of any two corresponding lengths. The scale factor is the same for all corresponding sides of similar figures. Are the figures dilations of each other? Look closely. They are. In fact, a dilated figure is always similar to the original, and similar figures are always dilations of each other. Similar figures have congruent angles, proportional sides, and are dilations of each other. Let's try some problems. Which of the parallelograms are similar to the figure below? We know that similar figures have congruent angles, so first find all of the angles of the parallelogram. You know that opposite angles of a parallelogram are congruent, so this angle is also 55 degrees. What about the other two? You also know that in a parallelogram, consecutive angles are supplementary. So the missing angle is 125 degrees, which means both of these angles are 125 degrees. Looking at the answer, you can cross off any whose corresponding angles do not match that of the figure. So you can cross off number 3 and number 5. Now test the side lengths and make sure that all the side lengths are proportional. For answer number 1, test the scale factors for corresponding sides. They are both 1/2. Since parallelograms have congruent opposite sides, it means all the sides between the two figures will be proportional. So answer number 1 is similar. What about answer number 2? Notice the parallelogram is exactly the same as the one in the problem. Are congruent figures similar? They have equal angles and proportional sides, right? Which means the scale factor would just be 1. So the figure in answer number 2 is similar as well. What about answer number 4? Test the scale factors. The scale factors for the top sides is 3, and the scale factor for the right sides is 2. So this one is not similar to the original. So figures number 1 and 2 are similar to the original figure. Do you think there is a limit to the number of similar figures an object can have? There isn't. Every figure has infinitely many similar figures. Let's try the next problem. In the diagram below, segment AB is parallel to segment CD. Which triangle is similar to triangle ECD? The first step is to find the angles of triangle ECD. Let's use the fact that AB is parallel to CD to find the first one. Remember that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. In the figure, AB and CD are the parallel lines, and AD is the transversal, which means that angle A is congruent to angle D. So mark D as a 65-degree angle. How would you find angle E? Remember that a straight line is 180 degrees. Along the line CB, you know that part of the angle at the intersection of angle E is 138 degrees. So subtract 138 from 180 to find the missing angle. So the angle is 42 degrees. Now to find angle C, you know that all the angles of a triangle add up to 180. So take 180 minus the sum of the angles you know. To find that angle C is 73 degrees. Now look for the triangle in the answer that has congruent corresponding angles. So option number 2 would be the answer. Let's try another problem. Triangle STU is a right triangle with a right angle at T. Which triangle or triangles in the figure are similar to triangle STU? First, find all the missing angles in the figure. 2 out of 3 angles are given in triangle STU. To find angle U, subtract the known measures from 180. Label angle U as 50 degrees. Do you have enough information to find angle WTU? You do, since it's the only unknown angle in a triangle. So 180 minus 50 plus 90 is equal to 40. Since T is 90 degrees, angle STW is 90 minus 40 degrees, or 50 degrees. And lastly, angle SWT has to be 90 degrees, since it's the supplementary angle to UWT. Notice you have 3 triangles in the same figure, a big one and 2 small ones. It can be hard to tell if overlapping triangles are similar, so draw the 3 triangles in the same orientation side by side. Notice all 3 of them have corresponding congruent angles and are therefore all similar. So your final answer is that triangle STU is similar to triangle SWT and triangle TWU. In fact, here is a helpful rule that you can use with similar problems. If the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles formed are similar to the original triangle and each other. Okay, one last problem. Are triangles LPM and NPO similar? Why or why not? Since the triangles are overlapping, draw them separately to give you a better understanding of corresponding sides and angles. Notice you have 2 measurements for one set of corresponding sides, but unfortunately that's not enough information. So let's look at the angles. Angle P is congruent to itself, so 2 pairs of corresponding angles are congruent. What do you know about the third angles of the triangles? Angle M is 180 minus 65 minus angle P, and angle O is equal to 180 minus 65 minus angle P as well. That means that angle M and angle O are congruent. So triangle LPM is similar to triangle NPO because all 3 corresponding angles are congruent. In fact, looking back at the original figure, notice that these triangles are dilations of each other, where the point of dilation is at P. The Great Pyramids are similar figures. In fact, nature is made up of many repeated patterns of similar figures on a large scale and on a small scale. For example, the spiral shape of an enormous galaxy is similar to the spiral shape of a hurricane here on Earth. Can you think of any other places in nature where you see these spiral patterns? Look around you. You will see it everywhere, from your fingerprints to snail shells to the way certain plants grow. Similar figures are found all over nature, and math is just the language we use to talk about them. In review, similar figures have congruent corresponding angles, proportional sides, and are dilations of each other. Happy solving!